What's up, guys? It's Minx, and today's video we're going to be we're gonna not really change up things too much. We're gonna add something called culling. I guess I put the variable up here, but um, it's not really like full-on culling. We'll talk about what it is and kind of how it works. Um, and then we're gonna add in some. We're gonna make the movement better. We're gonna make it a little bit more snappier. We're gonna give jumping and stuff like that. So, what is culling and in the context of programming? So, culling, just looking like Google definition here. If we pull this up, overview in 3D rendering, the term culling describes the early rejection of objects of any kind. Objects draw calls, triangles, and pixels that don't contribute to the final image, while new techniques exist that reject objects at various stages in the rendering pipeline. So, we're going to implement a form of culling. It's not really going to affect any rendering right now. Probably uh, it's a little bit of premature optimization, but I think it's necessary considering the circumstance or considering what we're going to be doing. And it's not really like optimization, and it's not really. I mean, I guess it's a little bit. So essentially, what we're going to be doing is saying for the player to collide with something, um, if the distance between the player and the object we're colliding with is greater than is greater than our culling distance, then don't collide with it. So we're checking less collisions. Essentially, we're going through and doing less work. Um, which right now we have one thing to collide with. We may have two, three things on screen at any point. It's not a big deal. But when you start like doing like a level creator and stuff like that has a bunch of stuff to collide with, then it's kind of it starts to become a bit bigger of a deal. So we're gonna do it real quick. It's not complicated. It's real super easy. And even when we like change this up to like check for walls as opposed to and stuff like that, as opposed to checking for something like hazards, culling will still be able to easily be applied. So this is not like a bad thing or anything like that. And it's a good thing. So let's go ahead and get it set up. The only thing we really need to do is so set up a collision culling distance, and I set it to 400 F. So if you're 400 away, then the cube's not going to collide with you. 400 distance away from our player. It's dynamic. It says when you play a multiplayer game, there's actually an example of this, the great example. There's an SCP game, I think it's SCP 5000. I think it changed names when it was a zombie game. The culling was, I don't know what would go on with it, but the way culling works in a game like that is it follows the host around. So you have to be a certain distance within the host. I think Ark Survival Evolved does this on player-hosted rounds, where you have to be a certain distance. That's why there's a tether, as opposed to a dedicated game where you get to go the whole map. But if you go out of that range, your game's rendering that stuff, but the host game isn't. So what'll happen is you'll fall through the map or some shit like that. So um, that's similar to what we're doing here, I guess you could say. It's a culling distance around the main player, and if that doesn't exist, then it disappears. So all we need to do is head into here, and where we continue, so where we skip the object, because there's no need to like dynamically deregister and register objects right now. It might actually be a cool idea, but if we do it, we're not doing it in this for each loop, because that's not a good idea. Instead, we're just going to say if object is equal to this, or so we say vector2, it's a vector2 dot distance, so we get the distance between the two. This is a normalized distance, if I'm not mistaken. Oh, excuse me, the Euclidean distance. So it's a simple way to just check, hey, what's the actual distance between these two? And it would be this dot position and obj dot position. We already got a reference. And it's if distance is greater than our what is it, collision culling dist. So if it's greater than 400, we skip it. Now, this is great. This means we're going to just skip a bunch of unnecessary stuff. So like, for example, you're at the beginning of the level. Why do you need to collide with the ending of the level or something? It's pointless. So now this is cool. However, this introduces something that we need to keep in mind for the future. If we hit start here, we're good here. But keep in mind that this object starts here and we fall off here. So we're 400 pixels away at this point. So how do we fix that? There's two ways. We could change how the distance checks. We could check, the point between here, but the point of culling distance is for optimization. Um, so that's a little unnecessary. What we can do is go into our game window And actually, we'll start our test object. So what we do is, and this is a good idea anyway for this thing because we're gonna need more of these for like boxes and stuff. So say vector2, we'll say position and vector2 scale. Oops, there we go. And just change this dot position equals position, and this dot scale equals scale. There we go. And then when we go to game window, so let's go ahead and get rid of this, and we'll just say, let's see. So we'll do like 100 width. So for I in range, int I was thinking of Python. So for I0, I is less than, so it goes into 1280. So we'll do I is less than, we'll just do 14. I plus plus. So we need to say, wow. We need to say, what is it? Because we don't automatically do it. We'll just do the create a new. So underscore equals new test object, and it'll be this, and the position. So it'll be vector2. So new vector2, and this is where we do a little bit of math here. So I actually do both of the new vector2. So for the second one, it's always going to be, we'll just do 100, 100. That's fine. For the position, so x is going to be what changes. So we'll do a comma first. We'll do 0, comma, and then y should be, let's see, 720, so 670. That's fine. In fact, we could do 620, make it 100 tall. So x would be equal to I times 100. So it starts at 0, so it'll be at 0, then 100, then 200, then 300, then 400, all the way up to, looks like 1300. So should we go all the way to the end? We hit start. And now we shouldn't end up falling through. And in fact, I think we could go a little over. Yeah, because it goes a little past it, which is fine. So that's how we would do movement not movement, but culling and prevent us from falling over. But this also allows us to um, kind of get an idea about how level generations can be made. So we don't want to do like one big solid block. I don't know for optimization purposes if that's even a good idea, like how beneficial that is. I guess the collision makes sense to be easier, but otherwise, when we do like level generation, like when we load a level in here, we could see how it's like, okay, we got 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, so we might be able to utilize that to it's like, all right, when we make a level, we pull it from like a list of characters that designate what's supposed to be in that spot. But we'll see. So that's for now. That's good for our floor. Create floor out of test objects. Jeez. Might end up renaming that to like debug obj or something. But okay, so let's move back to the player here. So I promised we would do some more, some better movement, like jumping and stuff like that. So I'll be honest, this is going to be sort of more like a, not really bait, I guess, but it's probably going to change over time with the player because the movement kind of can get like complicated because you got a lot of stuff to account for and stuff like that. So let's go ahead and drop in a few variables here. So we got friction, gravity. We'll do float, jump height, and we'll just do 60F for now. These might change later, but we'll just get some default values. So we got float, max, max, really? Max X speed. We'll set that equal to 10. Don't need the player zooming off too much. Float, max Y speed. I set this to 60 because we need to be able to jump, and we use the Y speed to jump. And the player doesn't have as much control over the Y speed as they do their X speed. So we say the X speed can only be 10F. They only need to be moving that fast. With the Y speed, they wouldn't normally be getting up to 60F, except for when they're jumping. So that's perfectly fine. We'll say bool is jumping equals false. We need to be able to determine if we're jumping. We need to determine can jump if we are in the process of, or if we are allowed to jump. We'll set that true by default. Bool, we want to be able to check to see if we're falling. It's false. And did I set like a speed at all, like a move speed? No, we'll say low move speed. equals 5f. So instead of like setting up like a hard coded values like it did down here, like we just, it's like, oh, x dot speed dot x equals 5, no, absolutely not. So when we get into our update, we already do this, right? The first thing we do is apply gravity and apply friction. Okay, so we've already done that. We set up our rectangle at a specific spot on the update. So we moved our physical location. Okay, so that's fine. This yellow. Oh, because it's a vector. Okay. So we're applying friction to our y and our x speed. I don't know if I want to do that. Well, okay, let me see. So the thing is, we're gonna apply this to um we're gonna comment this one out. We're gonna apply this to x and not y. So we're gonna say this dot speed dot x times equals this dot friction, and friction is just a float, so it should be fine. Yeah, okay. So the reason for that is when we're falling, it shouldn't be slowing us down. It should only be applied or affected by gravity. And then when we collide with something on the floor, we're good. And gravity is always going to be getting added every frame. So regardless, we're going to be going back down to collide with something or die in a pit of death. So I don't think we need to be applying Y friction at the moment. If we do at some point, then we do. Okay. So now let's go ahead and get into jumping. Jumping is interesting because it's like goofy sometimes. So how do we know if we can jump? Well, we need to check if we can jump. How do we know if we can jump? Well, we need to be colliding with the floor. How do we know if we're colliding with the floor? That is actually something we can do fairly easy with our collision system. So you'd think there's no easy way to do it. So checking collision, no, not here. This absolutely the fuck not. No. So come up here to check collision. So we're checking horizontal collision here and we're checking vertical collision here. Now, horizontal collision and vertical collision. Well, okay, ignore that. Never mind. For both of them. So it tells us that our math.sign is based on which side we're colliding with. So if we're colliding on our butt, then we are at positive. If we are colliding with our head, then it's pushing us down essentially. Very well. Yeah, essentially. So what we can do is say, and it's outside, or no, it's, excuse me, it's inside this while loop. So while this is true. So if math.sign this dot, what is it, this dot speed, because it's speed that's being set, dot y, is equal to 1. So if we are on the ground, this is essentially saying, we'll just comment here, if colliding on bottom of player. We can say this dot can jump was true. This dot is falling. We know we're not falling if we're colliding. And this dot is jumping. We also know we are not in the process of jumping if we are colliding with the bottom. So now we can also say console.writeLine on the ground. We're going to test this out just to make sure it works. So we should be able to start. And well, unfortunately, without a thing, we're going to fall off the edge here. And we can see it stops. That doesn't really help because we don't have jumping. So we'll comment this out for now. We can come back to it later to confirm. So to actually jump, what we can do here is we can do a little bit of logic. If this dot can jump, so we don't need to do that like up there. It's like, oh, can we jump? No, we just set the variable up there and this does the check for us. We would say this dot change position, or not, excuse me, this dot speed dot y minus equals, because we're going up, minus equals this dot, do we do a jump height yet? We did, okay, jump height. So what is our jump height? What did I set it to? Jump height is equal to 60, that is our max. So theoretically, we should be able to jump now. Oh, Okay. Uh, wow. And went so fast we fell through the floor because the X collision at the speed rate we went was below this. So we have max speeds. We should probably actually clamp stuff. I don't know if our thing has clamping. Let's see. C# math clamp. Can we clamp a vector? Let's see. Vector clamp. Oh, here we go. So we say this dot speed dot clamp, or no, say vector 2 dot clamp. So we got vector. Oh, cool. Okay, so what we'll do is we'll say vector 2 clamp this dot speed, and then we have to give it. Yeah, I know it's taking a minimum and a maximum vector. So instead of doing max x speed and max y speed, we could say uh, vector 2 max speed equals new vector 2, and it'll be 10f, 10, well, yeah, 10f, 60f. Then we can comment these two out. And then to do minimum and maximum, say, where'd it go? This. Shit. Let's see. So we'll do, so minimum is negative this dot max speed, and maximum is this dot max speed. However, I think max speed, the y needs to be inverted. Because max speed, so max up needs to be negative 60 and max down needs to be 60, right? So, because we're applying the same thing. So this was talking about where it's like vertical stuff is stupid when they do this with the fucking the canvas. That's okay. So we have our max speed kind of working. I think 60 might be a little bit much, huh? It's not like I'm hitting that very much. It's funny. The 60 wasn't going that high in my other one. Let's see here. Miss anything? Max speed. Let's change this to 60 and see what happens. It's just as bad. We've got to play around with the values, I think. Give me 1 second here. Take a look at my notes for the speed stuff. Let's see, and we are. Let's do this. Console.WriteLine. This dot speed dot y. So it is bypassing the rule of 60. That's the issue. All right, we'll use the clamp, but we won't do it this way. So we're gonna get rid of the vector 2 clamp here, and we're gonna use a math clamp, math F clamp or whatever it's called. Get out of here. So C# clamp, math.clamp. Okay. So this dot position dot y equals math.clamp. What? Let's see. We're gonna leave it like this. This dot position dot y, and this dot max x or max y speed is the. See, it knows what it is, but it also doesn't. Really. And then, well, that would technically this dot max y speed again, and this would be the negative version. Is that a joke? do system.math. Guess I'm well, it looks like it's not coming up, so that's okay. We can just do the if checks here, unfortunately. So we'll do a just do a clamp function. So say private say so we'll do private float clamp, and I'll be float value, float min, float max. Looks like it kind of gets an idea. So if let's see here, that's a little ridiculous. Okay, so if value is less than min, so if it's less than or equal to min, get rid of this extra, turn min, get out of here with that stuff. If value is greater than or equal to max, turn max, else return value. Get, I hate this so much. Return value. There we go. Pretty straightforward. I'm pretty sure there's probably a better way to write that, but whatever. So what we say is this dot speed dot y equals this dot clamp this dot speed dot y, and min would be this dot max y speed, and the minimum would be, well, okay, so we have to do negative, so that would be negative still, and then the max would be this dot max y speed, because it doesn't actually know the difference between the two. So this is just the negative or positive value. It doesn't know whether it's going up or down. But the negative is still the negative. So even if that's going up, we still can't, have it be going past negative 60. So that would still be the minimum, even though it's like the opposite direction. I think that might have been where I got tripped up. But we're gonna do the same thing for x. So just do this dot clamp, change all these over to x speed, and we can hit start, and that should restrict us down to what we need. So 60 is still a bit high, and it looks like it's not. Oh yeah. Oh, we're not setting to this dot can jump to false ever. But okay, so we've got a little bit better, and that's actually probably why we're going. So that's probably the other reason why we're going so high so fast, is because we're still adding it on even when we're in the sky. So something else that we can do, we could say. So else. So if we are not, so we know if math.sign is not equal to 1, that we cannot jump. We want to set false here. Actually, we don't want to have to do all this extra stuff. At the beginning of the frame, so we check input here. So yeah, what we can do is actually set up a variable like right up here at the beginning. So we cannot jump by default. We can only jump if we've determined that we are colliding on our butt. That should be fine. There we go. Much better. So now, if we are on the ground, which I can already tell you that we know this is working. Like I don't even need to. Oh, that's interesting. And I guess this is one of those scenarios where like we could have a double input. So right now, I dragged the window to get it out of focus, and if I move left to right, W was still added. W never got removed. And this is one of those scenarios where we could have a double. I didn't even realize this would be easy to find. So we prevent double input with those if statements that we did earlier. But anyway, going back to this, we know it's working because we're not adding Y when we're in the sky, so we know the is ground check is working. We can 100% confirm this without beyond a doubt by doing this, and then start. We can see on ground is being added. This we could say you can see that it only gets added more when we're like actually on the ground. So very cool. Okay, so we know if we're jumping is falling is or can jump. Um, so we want to set. So if we jump, so let's actually we'll, leave that there. So when we jump, we want to say can jump. We want to say this dot jumping equals true. We're gonna probably, I don't know if we're gonna do much with is jumping, but it might be relevant later. We want to store this. So what I did with my when I was working on this similar thing in JavaScript was I stored a lot of these variables. So I knew when the player had jumped, like if they were going up, when they hit their peak, when they started going down. We had variables for all those. It made it easier to do wall jumping and stuff later on because it's like, all right, how do we interact with this wall? You know, what are we doing? Are we up to it? Are we falling down on it? How does that work? Because if you're going up, you probably aren't going to be like setting up a wall jump. But if you're falling down, you start sliding down. And you could do like wall climbing if you're going up, stuff like that. I don't know. So got that. We're gonna do move right. Let's see, speed. Uh, we'll say this dot move speed. Left. This dot move speed. So instead of saying equals, let's say plus equals. And then move speed's going to be a little bit lower. So if we lower this down to like 3F, this allows us to start a little bit slower, but build up speed. So, oops, probably set that to negative. Left is negative. Curious what happens if I go down. Okay, nothing. So you can't really tell because of like how fast we're moving. But you instead of just like the snappy movement of like a messed up game, like a hardcore or like a impossible game. You move like you start off a little slow. It's not like a big change here. It's pretty responsive and snappy. I feel like we're in. I can't tell. I don't know. But we start off a little slower and then we immediately build up to the max pretty fast. So we could even set this a little bit lower, maybe like point, let's say like 2. Because we still build up to the max speed because we're adding it. There we go. But then we slow down at the friction. This way we're not like we're not feeling like I don't even know what it feels like. It just feels bad, This feels better. So that's how we set that up. We've got our jumping. We're pretty much at where I was when I showed the original example on the thing. So we've got movement, better movement. We've got some setups. We've got culling. In the next video, we're probably going to start loading levels and stuff. So like, for example, we're going to write something to, we're not going to like do a level designer just yet. I don't know how far down that is. I don't know when. We are going to be doing that, but not yet. We're going to do something to actually load a level. We're going to start that process. So like, for example, we input some information and then it puts down these walls for us and stuff like that. And after that, we'll probably start getting to advanced movement. I want to get movement done. I want to get like the gameplay some of the gameplay aspects done before we start doing anything like a menu. Because we will start doing like menus and stuff at some point. But the gameplay is more interesting than making a stupid menu. Then we'll get images, and we'll start. This thing will start getting a little more interesting than just a stupid little cube that bounces around. Though I do like this cube. He's pretty sick. So anyway, thanks for watching, and have a wonderful day.